Hello, Assalamualaikum guys. Welcome back to the second half of the second semester. Okay, so we're gonna continue on our topic on special probability distribution or statistical model for discrete random variable. So in particular, we are going to familiar ourselves with binomial distribution. Okay, before we start, I give you like one situation. Okay, so you imagine that you are a quality control manager supervising thousands of sambal nyet by Karahan being produced daily. So many of the netizens complain that the weight does not conform with what's stated on the jar, which is satu jar tu I think bantai lah 300 grams. Okay, so now how can you find the probability that 10% of the jars have weight less than 250, and can you find what is the mean number of jars with weight less than 250 grams, and should you send the machine for a repair or check on the CCTV kan. So kot lah ada worker tengah buat kerja, so dia colik-colik sikit kan sambal tu kan. So as a quality control manager, these are the things that you need to check using statistics. This is doable lah. Alright, so from what you have learned in previous weeks, masih belajar discrete and continuous random variable. So it is possible for you to find the probability, mean and variance if you have the PDF. Okay. Alright, so now how do you get the PDF? Macam mana you get the function? Okay. So in statistics, so there are many distribution or statistical model that you can explore on your own, but at the most common one and what we covered in the foundation level is the binomial and Poisson lah untuk discrete. For continuous random variable, we're going to cover normal distribution only. Okay. Alright, so now how do you identify a binomial distribution or model? Okay, so a binomial experiment should satisfy the following four conditions. Okay, so the first one is that there are n identical trials, and each trial has two and only two outcomes, that is a success or a failure. Okay, so we denote probability of success as P and the probability of failure as Q. Okay, so I would like to relate back with the situation that we had for Sambanyet. Okay, so per se that you choose a few jars randomly, okay, and then you check on whether this jar is less or greater than 250 grams. So now the third one is that, so the probability of success and failure will be equals to 1. Okay, so there's only two outcomes saja lah kan. So P plus Q will be equals to 1. So and P and Q remain constant for each trial. And then the last condition is that the trials are independent. Alright, now let's look at the PDF for binomial distribution. Okay, so a random variable x. Okay, so x is per se the number of jar that has way less than 250. Okay, so x is defined to have a binomial distribution, and we denote it as binomial, or macam ni lah, we can write as B and P. Okay, the probability distribution of x is given by this one. Okay, so that's your PDF. Okay, here the PDF ni you can also write it as NCR. Okay, P power x Q n minus x. Okay. Alright, so x is 0, 1, 2, 3 up until n lah. So meaning that x is a discrete random variable. Okay, and P can take up 0 to 1. P is the probability of success. Okay, Q is the probability of failure. N takes positive integer, and P plus yang ni sebenarnya datang daripada P plus Q equals to 1 lah. Okay, so further, the mean and variance of a binomial distributed random variable is given by NP, and sigma squared, the variance is given by NPQ. So you can always prove this. Okay, kan kalau kita have the mean kan, mean is the EX kan. Okay, so EX ni is summation of x P x equals to x kan. Okay, so kalau you derive this, okay, you akan dapat sama dengan N and P kalau you guna the probability here ni kan. Okay, you take as this one lah because it's a binomial distribution. Okay, so you akan dapat NP, the variance will be NPQ. Okay. Alright, okay. There's another distribution called as Bernoulli. Okay, now nama I kan. Okay, Bernoulli. Okay, so which is this Bernoulli ni is actually related to binomial distribution. Okay, so kalau you have a binomial distribution, it represents the number of successes and failures in n independent Bernoulli trials. the Bernoulli distribution pula sebenarnya represent the success of a failure of a single Bernoulli trial. So maksudnya kalau you have multiples of Bernoulli trial, so sebenarnya you akan ada a binomial distribution. So I'll give you an example. Okay, so example, we are flipping a coin once. Okay, and X is the event of getting hit. Okay, then X will be following Bernoulli with P equals to half kan, sebab the probability of success for getting hit is 50-50 kan, so P is half. Okay, so maksudnya you can write because X is the event of getting hit and we are flipping a coin once only. So X ni will be follow Bernoulli with P equals to half. Okay, so whereas kalau you are flipping the coin 4 times, so you have n independent experiment. Okay, so X will be following okay, I letaklah X1 dengan X2 kan. So X2 will be binomial with parameter n equals to 4 sebab you flip 4 times. Okay, so and P is half. Okay, so kalau you flip once, it's a Bernoulli. Kalau you flip 4 times, so it's the same experiment that you do tapi 4 kali. So we're gonna have X is the event following binomial distribution. Okay, alright. Okay, now let's look at one example. Okay, what is the probability of getting 3 hits when we toss a fair coin 8 times? Okay, so from here kan, we can define X. X is the event of getting hit. Okay, alright. So X sebab you've toss the coin 8 times, so dia akan follow apa, Bernoulli ke binomial? Binomial lah kan. So binomial with n equals to h, and what will be your probability of success? So that will be half lah kan, sebab we are assuming it's a fair coin. So to get probability of X equals to 3 kan, getting 3 hits. Okay, so you can use the binomial PDF mana tadi the PDF. So NCR P X Q N minus X. Okay, so you're gonna get apa, 8 C what is your R? R ni sebenarnya 3 lah, so this is your R. Okay, and C 8 C3 your P is half power X kan, power H. Q is half juga, that will be N kan, N is 8 minus 3. Okay, so you akan ada you can use your calculator lah. Okay, so you will get berapa 0.2187. Okay, so that's your answer. Okay, now this is for A. For B pula, okay, what is the probability of getting 2 number 1? Okay, so we can define X ni as getting number 1. Okay, when we roll a fair die 5 times, so X would follow apa, binomial with n equals to 5, and your P will be what? Ni roll a die kan, so 1/6 lah kan. Okay, so you want to get the probability of X getting number 1 2 times, 2 getting 2 number 1, so X equals to 2, you will get what 5C2 1/6 power 2 5/6 lah, because your Q is actually 1 minus 1/6. Okay, power berapa 5 minus 2. Okay, so you're gonna get 5C2 1/6 power 2 5/6 power 3 lah. Okay, so you will get berapa 0.16075. Okay, alright. So tak habis. So find the mean and variance of the distribution. So if you like to find the mean, so the mean is what just now NP kan, so that will be 8 times half lah, so which is 4 lah. Okay, the variance okay will be NPQ. Okay, so that's 8 times half lah. Okay, so you get 2. Okay, now katalah using that example just now kan, you have the example A tu. Okay, you have head of head of tail. You have a coin yang you toss 8 times. Okay, so kalau you nak cari the probability of X greater than X tu getting head kan, getting head greater or equal than apa sih 3 kan. So what you are going to do is that you akan tambah lah PX sama dengan 3 campur PX sama dengan 4 campur PX sama dengan 5 campur PX sama dengan 6 campur PX sama dengan 7 plus px sama dengan 8 kan. Okay, tapi yang ni macam panjang lah kan. Lebih baik you buat this is equals to 1 minus p x less or equal than 2, betul tak? Okay, so it will be simpler to calculate. Okay, so now that is when you have n equals to 8 saja tau. That is why we stop at x equals to 8. So maksudnya x tu is the number of getting hit, sebab you are tossing the coin 8 times only, so the possible numbers of getting hit is only 8. Okay, so now imagine the situation where you have a number of trials or binomial trials 100 times. So katalah you ambil sampel sambal nyet tu kan, so you ambil 100 jars. Okay, so you nak cari berapa the probability of having 50 more than 50 jars with weight less than 250 grams. Okay, so kalau macam tu memang matilah you kan. You nak tambah apa x sama dengan 51 campur 52 campur 53 50 sampai 100 kan. Okay, so that should be a way a simpler way lah to do this. Okay, so actually Murdoch and Barnes kan, dia ni memang raja lah kan. So dia buat binomial table Okay, so bukanlah dia ni author je for this particular statistical table. Sebenarnya statistical table tu you pun boleh buat sendiri kan. So yang ni dia compilekan a few common statistical distribution dalam satu buku, so you can refer to it. So macam dulu kan you ada buku sifir lah masa sekolah-sekolah kan, sekarang dah tak gunakan buku sifir tu kan. Okay, so the concept is the same lah. Okay, so you have the binomial table in Murdoch and Barnes. Okay, so this table ni I give you in soft copy dekat MS Team, so you go and check it out. Okay, so the important thing is this table kan use more than or equal. Okay, dia kiranya dia tabulate all the probabilities. So for x greater or equal, okay, which is dia guna ni Okay, so okay, I bagi you tengok lah. This is the binomial table. Okay, so you can at the top of the table you kena baca dulu tau. Okay, what is this table for and how to read it. Okay, so P in this table is given as a probability of success. So sama je lah dengan notation yang kita guna just now. N is the number of trials. So the table gives the probability of obtaining R or more success in n independent trials. Okay, that is you are having a sum of x daripada R up until n. So contohnya kalau you want to find Px greater than 2, greater than 1 lah. Okay, so okay, so for instance katalah you want x so say you have x follow binomial, your n is 2, okay, and your p is 0.04. Okay, so that's your p, this is your n. Okay, alright, so you want to find px greater than 1. Okay, so you, sebab the table is giving the property of obtaining r or more success. Okay, so maksudnya you tengok this is n equals to 2, p you have p equals to 0.04 kan. So your r here is actually 1 here kan. So you tengok lah yang ni dia akan cross r kan. Okay, yang ni r equals to you want r greater than 1. Okay, so your probability will be here 0.0784. Okay, so that is how you get your ni lah probability using the statistical table. Okay, alright, so ni you boleh tengok lah. So the table is giving you different values of n, different values of p. Okay, up until n equals to 100. Yang p ni up to 0.05, 009, ada p 0.05 kan. N ni adalah sampai 50 ada tak n sama 100? Ada. So you have the table up to n equals to 100. Okay, p equals to 0.5. Okay, lepas tu itu table 1. Table 2 will be Poisson lah. So we're gonna cover this in next week. Okay, so that is your statistical table. Okay, now let's look at another example. Okay, so I tukar sikit example ni sebab nanti I tunjuk kat you kenapa I tukar 6 to 5. Okay, so you would like to find you have x follow binomial with n equals to 5 and p equals to 0.2. Okay, so find by using the binomial formula and table for px equals to 2. So for px equals to 2, x is following binomial, your PDF is NCR p equals to x q n minus r. So your n is 5 c2, your p is 0.2 power 2, times Q is 1 minus P, which is 0.8 power 5 minus 2, 3. Okay, so nanti you kira lah, you akan dapat lah. Okay, now, so how about if you want to use the table for Px equals to 2, okay? So, Px equals to 2, kan? If you want to use the binomial table, kan? Your binomial table just now give you the property of having R or more, okay? So, kalau if you want to find Px equals to 2, what you do is that you kena cari property of x greater or equal than 2 minus Px greater or equal than 3. Okay, so baru you dapat x equals to 2. Okay, so now let's have a look at the table. You have n equals to 5, p equals to 0.2. So p equals to 0.2, 5, n equals to 5 here. So you nak berapa tadi? R 3 3 and 2 and 3. So you akan dapat 0.2627. Okay, 0.2627 tolak dengan 0. X greater than 3 will be 0.0579. 0.0579. 0.0579. Okay, so you will get your answer dah lah. Okay, alright. So for 2 Roman, okay, kalau you want to find Px greater or equal than 5, so this will be Px equals to 5 plus Px equals to 6 saja kan, sebab tak lah, Px greater than 5 sebenarnya sama dengan Px sama dengan 5 lah kan. Okay, so that will be 5C5 0.2 power 2 0.8 power 0. Ni 5 lah. Allah. Ni 5, ni power 0. Okay, so you will get your answer lah, you calculate. So kalau you nak guna table, so you cari je n equals to 5. Okay, 0.2. So here lah, you punya jawapan will be 0.0003. Okay, so your answer will be here. Kalau guna table, 0.0003. Okay, so you compare lah with the formula. Okay, so basically, whatever that you calculated using the formula will be much more precise than whatever it's in the table. Okay, sebab table ni they cut off until 4 decimal saja. Okay, so tapi jawapan ni akan seriously close lah. Okay, alright, so that's 2 Roman. For 3 Roman, okay, Px less than 2, yang ni kalau you nak use the formula, that will be Px sama dengan 0 plus Px sama dengan 1. Okay, so Px equals to 2 is not included sebab you nak x less than 2. Okay, so yang ni you boleh guna lah NCR whatever not lah. Okay, so kalau you nak guna the table, okay, property of x less than 2 will be equals to 1 minus Px greater or equal than 2. Betul. So you akan dapat 1 minus Px greater than 2 just now is 0.2627. Okay, so you akan dapat jawapan dia. Okay, alright. Sama juga yang 4 Roman ni I skip lah. So for 5 ni, you would want to have Px in between 1 and 4. Okay, so in between 1 and 4, you akan ada Px sama dengan 1 tambah Px sama dengan 2 plus Px sama dengan 3. Okay, 4 ni that's not included. Okay, so you boleh guna the formula and see, 5C1 0.2 power 1 0.8 power 4 and so forth lah. Okay, kalau you nak guna the table, that will be berapa? Px greater or equal than berapa? 1 kan? 1 kan? Okay, minus Px greater or equal than 4. Okay, so you imagine that you have 0, 1, 2, 3, 4, 5 and so forth lah. You ada sampai 4, 5 je kan tadi, because you have n equals to 5. So you have 5 trials. Okay, so kalau you nak guna table give you the property of having R or more. So you nak daripada 1 sampai 3 je sebenarnya kan, because it's a discrete. Okay, so what you do is that the property of x greater than 1, okay, you minus Px greater than 4. So you will get 1, 2 and 3. Okay, so kalau you tengok the table, x greater than 1 is actually berapa Nampak? Yeah. Px greater than 1, your answer will be 0.6723. Greater than 3 will be greater than 4 lah. Tolak 0.4 lah kan. Sorry. Betul lah. X greater than 4. Okay, greater than 4, your answer will be 0.0067. Okay, so nanti you tolak and you get the answer. Okay, alright. Okay, so now let's look at another example. Okay, so in a survey, it was found that 20% of all working people exercise every day. Okay, so that's just very small lah kan. So macam I pun tak exercise every day lah kan. So I'm in the 80% of the apa ni percentage lah. Okay, so we will still regard this as the success lah. Success means people who are exercise every day. So the proportion or the probability will be 0.2. A sample of 10 working people. So meaning that you find one person and ask them, you exercise every day or not? Okay, so dia cakap lah dia exercise ke tak macam tu. Okay, so you do the same thing. It's 10 independent trials. Okay, 10 different people that you do and asking the same thing. Okay, whether you are exercise or not. Okay, so basically you are having your n equals to 10. Okay, so x, what will be your x? X is the number of working people exercise every day. Okay, so x ni would follow what binomial with n equals to 10 and p equals to 0.2. Okay, so right, so you want to find the property that exactly 4 of them exercise every day. Okay, so the answer would be you use the binomial PDF. So you're gonna get n 10 c4 0.2 power 4 0.8 power 6. Okay, so you have the answer. Okay, ni at most 3. Okay, at most 3 means at most 3 apa x what less than 3 or greater than 3. Macam mana? So at most 3 is the maximum is 3. So you're gonna get less or equal than 3 lah sebenarnya kan. Okay, so that will be, yang ni ikut you. Kalau you nak guna table boleh, nak guna formula boleh. Okay, so kalau I tengok je lah table. So this one will be px greater or equal than 4. So I go and check out on my binomial table. For n equals to 10, p 0.2, r equals to 4. So I'll be getting the answer 1 minus 0.1209. Okay, so that will be your answer. You boleh juga guna formula. So you will be adding x equals to 0, x equals to 1, x equals to 2, x equals to 3. Okay, so use the formula. Alright, for C, at least 2 of them exercise every day. At least 2 means at least 2 is untuk C, px greater or equal than 2. Okay, so yang ni you can straight away look at the table. You're going to get 0.6242. Okay, alright, for D, 1 to 5. Okay, so untuk D, you're going to want to find px apa ni, that 1 to 5. So 1 to 5, this is px greater or equal than 1 tolak px greater or equal than 6. Okay, so you use 6 but you want 5 to be included. Okay, so nanti you akan dapat 0.8926 minus 0.0064. Okay, so you akan dapat 0.8862. That's your answer. Okay, alright, so now if you look at the table kan, binomial table, the p given in the table is only up to 0.5. Okay, so kalau lah you ada greater than 0.5 as the p. Okay, kata p 0.6 kot. So macam mana nak buat kan? If p is greater than 0.5, okay, so what we can do is that we can define another variable which take the opposite meaning of the initial variable. So for instance, kita ada x kan. Okay, x follow binomial per se 10 and your p is 0.7. Okay, so we can always have another variable y. Okay, so katalah ni macam ni, x is number of head. Okay, so p is actually the probability of success or probability of getting the head kan. So we can always define y. Okay, y will be the opposite lah, sebab binomial kan there's only 2 outcome, head or tail, success or failure, defect or non-defect. Can define y as a number of tail. Okay, ataupun yang ni success kan, yang ni is a failure. Okay, so okay, so you will get y ni, y will be binomial juga with n 10, but 0.7 ni kan, p is a probability of success. Okay, 0.7. So kalau the probability of failure or getting the tail, your p ni will be what, 0.3 lah kan. Okay, so using the apa ni, the opposite meaning of the initial variable. Okay, So you can use the binomial table. Alright, okay. So let's look at a few examples on when you have p greater than 0.5 kan, which it's not in the table. So but never mind, we can use the table anyway, but you have to define x ni, instead of x ni number of success, kita define as number of failure. So the p will be lesser than 0.5. Okay, alright. So x is the number of success with this. Okay, so find px greater than 5. Okay, so so kalau you tengok the p, it's not in the table. So what you can do is that we can define y. Y is a number of failure. Okay, so y would follow binomial with n10 and the q lah. Your q will be 0.2. Okay, so kalau you nak px greater than 5, okay, dia macam ni tau. Okay, kalau you nak x greater than 5 means ni x, ni y. Okay, x greater than 5 means 6, 7, 8, 9, 10. Betul tak? So you nak tambah x sama dengan 6 campur x sama dengan 7, 8, 9, 10. But now x is the number of success and you nak 6 success will be equivalent to berapa? 4 failure. 7 success will be equivalent to 3 failure. 8 will be 8 success, 2 failure, and then 1 failure, and then 0 failure. Okay, when you have all success, the failure will be 0. So maksudnya, instead of you looking at number of success greater than 5, you are actually looking for number of failure, which is y. Okay, and this y should be less or equal than 4. Okay, so kalau you tengok in your statistical table, you are going to look at this one, n10 p 0.2, okay, and r equals to 0.4. So you will get berapa? Okay, so you will get, tak ada lah, you kena jadikan dia 1 minus p y greater or equal than 5. Okay, sebab your table gives the property of getting r or more kan. Okay, so you akan dapat 1 tolak berapa, nanti you akan you tengoklah kat table 0.0328. Okay, so your answer will be 0.9672. Okay, so ataupun kalau you tak nak kan, you boleh je guna formula kan. So you are adding up x sama dengan 6, 7, 8, 9, 10. Tapi guna the formula, the P0.8, it doesn't matter lah kan, sebab you boleh calculate je. Okay, so that is how you use the table kalau you have P greater than 0.5. So now let's look at B block. Okay, so you have Px between 1 and 5. Okay, so 1 and 5 kan, you ada x, y kan. Okay, x you ada 1, 2, 3, 4 je lah, sebab 4, 5 is not included. So 1 success will be equivalent to 9 failure, 8 failure, 7 failure, 6 failure. So now what you're looking at is actually the failure which is in between 6 to 9. Okay, so y will be in between 6 and 9. Okay, so kalau you use the table, okay, this will be y greater or equal than 6 tolak py greater or equal than 10. Okay, so you akan dapat 0.0064 tolak 0. So kalau you tengok y greater or equal than 10 will be 0 lah. Okay, so that's your answer. Okay, so that is how you use the formula or statistical table to find binomial probability. So sebenarnya kalau you have the I don't know, your calculator yang advanced sikit tu, yang my one is the FX350 MS tu kan. So kalau you ada apa, class Wiz punya calculator kan, the model kan, yang advanced tu, sebenarnya inside your calculator pun ada the binomial probability. So sebenarnya tak perlu pun guna statistical table. Okay, but it's up to you. Kalau you tak ada calculator yang canggih tu, you can always refer to the statistical table. Okay, alright. And sebenarnya, okay, so now you might want to ask me, how do I get the binomial probability using the calculator? Okay, so you pergi cari balik manual you, okay, manual calculator you, and have a look at it and explore on your own. Okay, ataupun you tengok YouTube lah. Okay, alright. So memang sebenarnya statistical table ni kita dah jarang-jarang sangat guna, sebab we have statistical software such as R, SPSS, MATLAB, Excel pun sebenarnya boleh find the binomial probability. Okay, alright. So now before we end the lecture, we would like to have a short discussion on sambaniat Khairul Aming tadi kan. Okay, so now you nak cari the property that 10% of the jars have weight less than 250. Okay, and you want to find what is the mean number of jar with weight less than 250. So what you can do is that sebenarnya you boleh define X ni. X is what? Number of jars with weight less than 250 grams. Okay, so how do you get your N? Okay, so N tu because you are the quality control manager, ikut you lah, you nak cari N, you nak pick N tu berapa banyak sample. Okay, but of course the more the sample or the N lah kan, okay, the N trials the better, sebab you are actually representing the population lah. Okay, so contohnya lah Khairul Amin buat, dia produce daily about berapa 500 bottles kan. Okay, so tak adalah you nak ambil sampai 500 kan, cukup lah you ambil about 10% 20% kan, which is about ambil 20 lah at least. Selalu in statistics we take sample at least 25 ke macam 30 ke macam tu lah. Okay, so say you take 30 jars. Okay, alright, so your N will be 30. Okay, so okay, so P ni kan, one of the assumptions sebenarnya is that P should be constant. So probably the P ni you boleh ambil daripada existing data yang you ada, ataupun you boleh estimate daripada the out of 30 jars berapa banyak yang would have less than 250. Okay, so you know that your X will be following binomial with N and P. Okay, so with that information, you tahu your number of jars with weight less than 250 is following binomial, so you boleh dapat lah, you can find how many of the jars have weight less than 250, and you can also find the mean number of jars with weight less than 250. Okay, so you can also repeat the experiment. Let's say you ambil number of jars with less than 250 just now kan, less than 280, less than 295 gram. Okay, so katalah you dapat all these probabilities kan, it's very low kan. Okay, so this would be a very good evidence lah untuk justify to Khairul Amin's fan that sambanyik dia memang sebenarnya cukup-cukup lah 300 gram. Okay, as stated in the jar. Okay, so I hope that's the end of it. So let's just recap. Okay, the very important thing about binomial ni is the condition ni. You have to remember all these four so that you can identify whether the experiment or the trials is following binomial model or not. Okay, and sebenarnya PDF ni you tak payah ingat pun kan, sebab sebenarnya it's in the statistical book kan, dia ada dekat sini sebenarnya kat atas ni. Okay, so that's the PDF of the binomial table. Okay, alright, so thank you so much. So that will be only one video this week, okay, which covers everything about binomial distribution. So I'll be going on live for 1 hour. So I'll see you then. Bye bye. Assalamualaikum.